Now in this section we will discuss the recurrent neural network implementation with TensorFlow. So now we will discuss the following given table of content. First we will learn what is RNN, and then we will discuss how will a recurrent neural network work in TensorFlow, and next we will discuss application of recurrent neural network. After that we will discuss the limitation and the types of neural network. So also we will discuss why recurrent neural networks use in TensorFlow. In the end, we will discuss the implementation of RNN. Now first we will discuss what is RNN. RNN stands for recurrent neural networks, and it is a class of neural networks that allow previous output which are to be used as inputs while having hidden states, and it is also used in forecasting for recognition of data correlations and patterns, and it also helps to generate predictive output for sequential data by delivering similar behavior as a human brain. So in simple words we can say that it is a neural network that can be used when our data is in the sequence form, and the sequence can be of arbitrary length, and it is like a traditional neural network. Suppose a model with a single neuron feed by a batch of traditional neural net helps the user to model generates the result by multiplying the input with the weight and the activation function. So the below given figure tells us how we can convert a feed forward neural network into an RNN. So the nodes in different hidden layers of the neural networks are compact to form a single layer of RNN. In the given figure, W1, B1 and W2, B2 and W3, B3 are the network parameters which is used to improve the result of the model. Now we will discuss how will RNN work in TensorFlow. So here is the following given figure. So the given input M takes in the input to the neural network and passes it into the middle layer, that is U. So the middle layer U can provide multiple hidden layers, each with its own weights, activation functions and bias. So if you have a neural network where the various parameters of different hidden layers are not affected by the previous layer, then that the neural network does not have memory, then you can use a RNN. Now we will discuss some applications of RNN. So RNN is basically used in time series prediction, machine translation, image captioning and sentimental analysis. So for example, if we are talking about the time series prediction, the price of stocks in a specific month can be solved by using as RNN, and also we can given an input in one language. Now for this we are going to use machine translation. Suppose if you want to convert one language into a different language, you can use this RNN and can easily translate the input into a different language. So image captioning is the process of generating textual description of an image, and it uses both natural language processing and computer vision to generate the caption. Sentimental analysis is basically used for social media monitoring, or we can say customer support analysis. Now we will discuss the limitation of RNN. So it is quite difficult to propagate all this information when the time step is too large. So when a network has extra deep layers, it becomes untrainable, and also this problem is known as the vanishing gradient problem, because the gradients grow smaller when the network progresses down to lower layer, and the conclusion of this problem is that the gradient will stay constant, which means there is no space for improvement. So if the difference in the gradient is small, then weights change a little and the network cannot learn anything. Now we will discuss the types of RNN. So it consists only 4 types of RNN. First we will discuss one-to-one, after that we will discuss one-to-many, and then many-to-one. In the last we will discuss many-to-many. First we will discuss one-to-one. So basically it is a single input and single output type of neural network. And now we will discuss one-to-many. It has a single input and multiple outputs, and the real base example of one-to-many is image captioning. many to one. It takes multiple inputs and produces a single output. So sentiment analysis is an example of many to one in RNN. Many to many. It takes a sequence of inputs and produces a sequence of outputs. And the best example of many to many is video classification. Now we will discuss why recurrent neural networks RNN. RNN were created because there were a few issues in the feed forward neural networks. First is cannot handle sequential data and also considers only the current input, and it also cannot memorize previous inputs. So now we will discuss about the solution. So the solution of these problem is RNN, and RNN can be handled in a sequential data. So if we are using a time series in RNN, so for example RNN in time series, basically time series are dependent on previous times, which means past values include relevant information that the network can learn from. The idea behind time series prediction is to estimate the future values. Now let us understand the implementation of RNN by using TensorFlow. So here is the example of RNN. First we have imported the necessary libraries, and then we have used the MNIST dataset. And in this example we have images, and the images shapes are 28,28 pixels, and now we will treat as a sequence. So this means our input size and the sequence length. So 28 is the input size and 28 is the sequence length, and also we have 28 features. So this means we have 28 time steps in our sequence, and each time step we have 28 features. We have simply used the RNN model, that is simple RNN. So for this we have defined a sequential model, and the first thing we have done is to added an input, that is model.add, and within this we have specified the shape, that is 28,28, and this represent as a sequence length and the input size. After that we have added the RNN model. So there are different types of RNN models, that is LSTM, but in this example we have used the simple RNN model, and also the size of a hidden layer RNN model, and within this we have specified the number of inputs, and this is also the size of a hidden layer, and by default the activation function is an RNN, but in this case we have used the ReLU function. Next we must to do a classification. So we have 10 different classes in the MNIST data set, and then we have added a dense layers in the model.add, and we want to get the 10 output. Next we display summary of the sequential model. So as you can see that the output shape is given 28,128, and the dense output layer is 10. So after that we define the loss function. For this we have used the keras.losses.sparse categorical cross entropy function, and set the from logits value equals to true. After training the model, the output comes the 5 epoch value. So with this we have completed the implementation of RNN.